This is lesson 2.2 out of the Introduction to Algebra book. Lesson 2.2 is evaluating expressions. Okay, this is where we begin to actually plug in values for, oops, I don't know why I put that dot there. Plug in values for variables and come up with answers. So, evaluating expressions. We talked in lesson 2.1 about what algebraic expressions are, and now we're going to be working with them. So let's start with our warm-up. As always, warm-ups. All right, write an algebraic expression for each phrase. All right, so number one is the sum of x and 4. Okay, write out the algebraic expression over here for what these words represent. All right. Number two is 11 less than y. Number three, the quotient of w and 8. And the last one, number 4, 10 times p. All right, our I can statement for this lesson. I can evaluate algebraic expressions. All right, dark green pencil, draw our line, and we'll get started. Okay, so on this one, the notes are going to be one page, but we have 3 different note sheets to glue in here, and I want to show you, they just barely fit, and so when you cut them out, let's see, can I get all 3 of them in there? No, not quite. But when you cut them out, these first 2, go ahead and cut off the blank space at the bottom of them. Don't cut off the blank space on this third one down here, because I'm going to write a note at the bottom of it. So just the first 2, cut off the blank space so we can make all 3 of these fit here, okay? All right. So I'm going to start gluing these down. Of course, this is the time when you may choose to fast forward and get to the meat of it. Unless you just like watching me make my little tiny tadpoles, which is fine. Oop, that was not a tiny tadpole. I messed that one up bad. Let's see if I can get that spread around. All right. All right, oop, almost put it down upside down. Up here all the way at the very top in the corner for vocabulary. And notice that I cut off the blank space on the bottom of that one. All right, next one underneath there. And this one is evaluating expressions. The 2 steps for evaluating expressions. All right, and then the final one down here is our one that says good to know. And this one I did not cut off the blank space at the bottom of it because I'm going to make a little note down in there. Let's see if I can clean up this. There we go. Tiny tadpoles. That's what we call them in my class. teeny, teeny, tiny dot and smear it across. All right, and there's our good to know. All right, so as I always do, I'll take my yellow highlighter and just give each one of these a highlight. Vocabulary, evaluating expressions, and good to know. Okay, so starting with vocabulary. All right, so the vocabulary that we are introducing first here is evaluate. And evaluate means to find the value of an expression. What I usually say when you see the word evaluate, that means plug it in and solve. It means plug in the values they tell you the variables are being represented, and then just do the math. And you'll see examples of that very shortly. The good to know underneath there, what does it say? Okay, so some algebraic expressions have more than one variable. Oh, we talked about this in lesson 2.1. Have more than one variable. If this is the case, you will replace each variable with a given number. That means they're not going to be the same. Okay, different letters represent different values. Okay, and then it says, after replacing the variable or variables with numbers, you will use the order of operations to solve the value of the expression. And the value of an algebraic expression changes depending on the value of the variable. Well, that makes sense. If they tell you that x equals 3, fine. If at another time they tell you that x equals 5, then your answer is going to be, your final answer on your expression is going to be different. Okay, so then evaluating an expression. Let's see. I guess I did want to underline it. So we talked about this, but let's go ahead and underline. So if you are given more than one variable, you will replace each variable with a given number. Okay, and then here, then the next step is to use the order of operations to find the value of the expression. That's all there is to it. So it kind of restates that down here in our instructions. How do we evaluate an expression? Well, first, we rewrite the expression by replacing the variables with the given values. And second, we then follow the rules follow the order of operations to find the value of the expression. Pretty simple. All right, so I'm going to make a note right here at the very top here. When I say evaluate, when a problem asks you to evaluate, really all they're saying is plug it in, do the math. You'll hear me say that as kind of shortcut, okay? All of this tells you what it means to evaluate an expression. But shortcut means plug it in and do the math. And I'm going to show you how that looks here in just a minute. Let's highlight that with green. Okay? Plug it in and do the math. All right? So, first we're going to do a few examples here. They go pretty quick. And the first one is evaluate p plus 4 when p equals 7. All right? So, step 1 said to rewrite the expression replacing the variables with the given values. So, p is our variable, and the given value for p is 7. So we will rewrite this expression plugging in 7 for the variable. Okay, so now our expression looks like this, right? And 7 plus 4, then the next one is follow the order of operations to solve. Not much of an order here. We just simply have 7 plus 4, but that would be 11. Correct? All right, so that was how you evaluate p plus 4 when p equals 7. Okay, plug it in, do the math. All right, okay, here we go. Let's evaluate 9x when x equals 3. All right, same thing. plug it in, do the math. So I have 9, and then I have to plug in 3 for the variable x. All right, so I can't just put the 3 right next to the 9 there, can I? I mean, that would look like 93. Okay, so here's where either I would put a dot or parentheses. The more proper way to do it would be with parentheses. So now I have 9 times 3, and that's our expression now that's ready to be solved. So 9 times 3 is 27. This is step 2, solve. That's our final answer for that expression. So the algebraic expression 9x when x equals 3 is 27. All right? Plug it in, solve. All right, next one. Evaluate y divided by 3 plus 1 when y equals 24. Okay, don't freak out when you start seeing things look a little bit more complicated. Multiple operations doesn't change anything. It's still the same exact steps. First step is to rewrite this expression, plugging in the value for the variable that they give us. Right? So in this case, y is 24. So now I have 24 divided by 3 plus 1. Right? Now, order of operations tells me I have to take care of this division first, right? So 24 divided by 3 is 8. Bring over the rest of the expression. Right? And now I have 8 plus 9 is 9. And that's the answer. Okay? So, y divided by 3 plus 1 when y equals 24 equals 9. All right. Evaluate I'm not sure that showed up very well. Hang on a second, guys, while I erase that. Love, love, love my erasable pen. Shows up on camera so much better. All right, here we go. Evaluate c over 3, c divided by 3, plus a. Now we have two different variables, a c and an a. When a equals 4 and c equals 9. Okay? First step is to plug in our values for the variables. So c is a 9, so I'll write that. Plug it in over 3 plus a is a 4 plus 4. Now I use my order of operations to solve. And 9 divided by 3 is 3. Carry over the rest of the expression. 3 plus 4 is 7. And that's my answer. So c divided by 3 plus a when a equals 4 and c equals 9 equals 7. Right? Okay, one more. Evaluate, whoops, wrong one. Here we go. Evaluate a times b minus 5 when a equals 4 and b equals 2. Right? So step 1 is to plug in my values for my variables. A is 4, so I'll write this, and b is 2. In parentheses, I'll write the 2. Okay? Then I bring down the rest of the expression. Order of operations tells me I have to do this multiplying first. So 4 times 2 is 8. bring over the rest of the expression, and then 8 minus 5 is 3. That's my answer. Oops, where's my red pencil? Here we go. And that's my answer. Okay? All right, guys, that's how we do them. That's evaluate. Plug it in, do the math. All right? Very simple. All right, so there's one other problem you're going to see on your worksheet that we're going to do in this space here. So I'm going to draw a green line because it looks a little bit different. And that's talking about what they're showing in this last little notes here. Let's get this up higher. There we go. All right, so sometimes different values can be substituted for the variable in an expression. So one expression, but we're going to use different variables. And usually a table is used to organize the mathematical computations. The submitted values are called the input values. Okay, and then here's your algebraic expression. Now, I'm going to make one little change here because I'm not quite sure why they set this up this way, because very soon you'll see this a different way. This is really called an input-output table. And here's why. It's kind of like a machine, but let me draw something here. There really should be another column right here. Try to make this as neat as I can. Okay, and you'll notice it says X here, and then there's an algebraic expression, and then what should be in the title of that one should be Y. We input the values into this expression, and we get an output. Okay, that's the answer. Output values. That's the answer. Output values are in this Y column. So X goes in, the machine calculates it all out, that's the expression, and your answer that comes out is Y. All right. And so I'm adding that on there because I don't really understand why, unless I just don't really want to introduce to you at this point the concept of input output, but that's what's happening here, so I'm going to go ahead and do it. All right, so we're going to draw a real quick little table here. I need five lines. 1, 2, 3, 4, 5. Perfect. All right, so I'm going to draw a square using all 5 of my lines here. And down and across. And then I'll put a line here on each one of these. Alright, and this one is going to be X, this one is going to be Y, that's my output, my answer, right? And the expression that we're going to use is 2x plus 5. 2x plus 5. Alright, my input values are going to be 1, 2, 4, and 6. All right, here's what we're doing. This expression, just like we did up here, we're going to plug in this value in for the variable in this expression, and we'll get an answer. And then we're going to do it again, but with this value. Then again, but with this value. And of course, each time we do that, we'll get a different answer. Right? So here's the expression. 2, plug in the value 1, because that's the one I'm doing here, right? Plus 5, right? Well, that equals, now we have to do the math. Okay, 2 times 1 is 2. Carry over the rest, plus 5, okay? Gives us an answer of 7, okay? That's in the output. So the input into our expression was 1. The output, the answer, is 7. Right? So we'll do that going all the way down. All right, so next we have 2. For X, we're going to put in the value of 2, because that's what we've got right here. Carry over the rest of the expression. Carry down. All right? Order of operations tells me I have to do 2 times 2 first. That's a 4. Carry over the rest of the expression. Right? 4 plus 5 is 9. That's my output, my answer. All right? Okay, now we have 2. Notice it's just the same expression as what you see here every single time. I'm simply putting in a different value for the x. All right, so and the value I'm putting in this time is 4 plus 5. Now I'll do the math. 2 times 4 is 8. Carry over the rest of the expression. And 8 plus 5 is 13. That's my output. All right, and the last one, 2 times, now my x is going to be 6. 2 times 6 plus 5. Okay. 2 times 6 is 12. Carry over the rest of the expression, plus 5. And 12 plus 5 is 17. That's my output. Okay, so that's how you do an input-output table. They're talking about that over here. We talked about why I want this extra column there, and you'll see 2 examples of this on your worksheet. So that's why I'm including it in the notes. All right, I'm going to make one quick little note under here. This column is input. Okay, this is expression. And this is output, or your answer. Okay? All right. So those are the notes for lesson 2.2. And let's go ahead and move on to practice problems. Okay, so here's lesson 2.2 practice problems. The first section here says to evaluate each expression. Remember, when we are evaluating expressions, all we're doing is taking the expression, plugging in the value they give you for the variable, and doing the math. Plug it in, do the math, all right? So each time they will tell you what the value is for the variable, you rewrite the expression, plugging in the variable, and solve the expression, all right? And then the second part down here is evaluate each expression when A equals 6, B equals 2, and C equals 30. So each one of these expressions has multiple variables. The steps are still the same. You have to rewrite the expression, plugging in the values for the variables, and solving, all right? Just gives you a few more steps because of the extra variables, all right? All right, so let's go back to the top. Here are your practice problems. You may want to pause here, work these out. Now the second part, pause here. Okay, let's see how we work these out. All right, so evaluate each expression. All right, so number 1 says it says 12b when b equals 4. So we're gonna plug in 4 for b. So that would be 12 times 4, which equals 48. Okay, 12 times 4 is 48. I plugged in the value of 4 for the variable b and did the math. Okay, all right. 50 minus 3k when k is 10. Okay, we rewrite the expression, plugging in the value for the variable. So 50 minus 3 times 10, because k is 10, equals. All right. Now my order of operations tells me that I have to do the multiplication first. So I've got 50 minus 3 times 10 is 30. Okay, which equals 20. All right, number 3. Number 3 says 1/2 plus f when f equals 18. So we rewrite the expression, plugging in the value 18 for the variable f, plus 18. All right, and 1/2 plus 18 is simply 18 and 1/2. Okay. Now, I know sometimes I've got students that would look at this and they'd immediately see this fraction and they think they've got to do some kind of fancy setting up this number as a fraction and doing all the work. You know, don't overthink it, guys. If you have 18 and you need to add to it 1/2, then you've got 18.5. All right. V divided by 5 plus 7 when V is 40. So we're going to plug in this 40 for the V here. Rewrite the expression with 40 over 5 plus 7. My order of operations tells me I have to handle this division here first. So 40 divided by 5 is 8. Carry over the rest of the expression. And 8 plus 7 is 15. And there's my answer. Okay? So that's the evaluation part on the simple ones. Now let's get down to the ones where we have multiple variables. Okay, evaluate each expression when A equals 6, B equals 2, and C equals 30. All right, so rewrite the expression plugging in the values. So I have 3 times A equals 6 plus B equals 2. Okay, which equals, my order of operation tells me I have to do what's in the grouping symbols first. So I have 3 times 6 plus 2 is 8. Now I can do the multiplying. 3 times 8 is 24. And that's my answer. Right? Okay, and for C. In this expression, all I have is variables, but that's okay because they're telling me what the values are for those variables. So I'll rewrite it. C is 30, A is 6, plus B, which is 2. Okay. Order of operations tells me I have to take care of this division first. Okay. 6 goes into 30. 30 divided by 6 is 5. Carry over the rest of the expression. 5 plus 2 is 7. And so there's my answer. And number 7. Okay, this looks like it's a lot longer, maybe a little more complicated, but it isn't. Remember, the steps are the same. We're simply going to rewrite what we see here, plugging in the values. So A is equals 6 minus 2 times, what is B? B is 2. We put it in parentheses there. Plus 3 times C. What is C? 30. All right? Okay. I need to take care of these multiplications first. So I've got 6 minus 4 plus 90. Okay. Now working left to right with my subtraction and addition. 6 minus 4 is 2. Carry down the rest of the expression. Okay. And 2 plus 90 equals 92. That's my answer. Am I still in frame, guys? Oh, good. All right, 92. And the last one. We have 12 minus A. The value for A is 6. Over B, the value for B is 2. Right? I have to handle what's in on either side of this fraction bar first, because that fraction bar represents a grouping symbol. So 12 minus 6 is 6 over 2. Now I can do the division. 6 divided by 2 is 3, and that's my answer. All right? Okay, so for all of these multiple variable ones, that's how we worked out those. Okay, so let's take a look at your worksheet. Your worksheet, this top section here, a lot like the practice problems we just did. Nice and simple, one variable for each one of these. The second section of this is multiple variables, like we did on the second half of our practice sheet. And then on these here, these are your input-output tables, like we did in our notes. Your teacher may think different, but I would really like you to do this with your y here. And so you're going to take this expression, plug in these values for where you see x, solve it in here, and put the answer here. All right, do that for each one of these. Input your number into your expression, and the answer you get is in the Y column. All right? So that's your worksheet. That leaves us with your exit ticket. Exit ticket is right here for lesson 2.2. And again, I don't give you the answers for these. Maybe your teacher will, but she might use it differently. She or he might use it differently. That's the end of lesson 2.2 out of Introduction to Algebra. Remember, the only way to learn math is to do math, and mistakes are proof that you're learning.